Hello, in this video we are going to continue our discussion on section 5.1, solving systems of equations by graphing. Our essential question for this section is, how do you solve a system of equations by graphing? What does the solution represent? So go ahead and take a moment to pause the video and recall our first video on section 5.1 by graphing the equation that is shown, filling in m, b, and what the equation or what the line represents. So to graph the equation, I am going to start with my slope, which is m. My slope in this case is the coefficient on x, which is -3. We like to write slope as a fraction, so -3 over 1, or I can move that negative to the denominator and have 3 over -1. B is my y-intercept. Here, that y-intercept is a +4, or the point 0, 4. So I go to my y-axis and I put a point at my 0, 4. And then my slope is -3 over +1. -3 means I go down 3. +1 means I go right 1. So down 3, right 1, down 3, right 1, down 3, right 1. I'm going to go ahead and continue until I run out of graph. And that would be here. My next down 3, right 1 takes me off my graph. Now option 2, I could go up 3 for +3, but that means I need to go left 1 for the -1. So up 3, left 1, and we can see that those points are still all in a line. So up 3, left 1, and then I run out a graph from there. So now I connect my dots to the best of my ability, creating as accurate a line as possible. So my graph would look something like this. This line represents all possible solutions to the equation that I was given. So to the equation y equals -3x plus 4. So what this means is I can pick any point that I want. Let's say I pick this point right here, which has the coordinates +2 for x and -2 for y. So they're saying when I put in a +2 for x, I should get out this y value of -2. So I'm going to test that out. Y equals -3 times, I'm putting in a +2 for x. So all I did is I replaced my x. So that gives me -6 plus 4. So y is equal to -6 plus 4, and -6 plus 4 is a -2, so y is -2. So I put in a value of +2, and I got out a y value of -2, and that is exactly what this point on our line says. So any point on this line will have that relationship. If you put in whatever x value it is, you will get out the corresponding y value. It also means that any point not on the line, for example this point here, which would be a -3 for x and a +1 for y, will not work when I plug it into my equation. So I'll go ahead and test that out. If I plug in a -3 for x, I should get out a +1 if this point is a solution. -3 times -3 is a +9 plus 4, and 9 plus 4 is 13. So we're saying y is 13. But the problem is I put in a -3 for x, I got out a +13 for y, but this point says if I put in a -3, then I should get out a +1, and I don't. So that point cannot be a solution to my equation. So the only possible solutions to my equation are those that are on this line that I've drawn. So to solve a system of equations by graphing, our goal is to identify the x and the y values that make both equations true. So I want an x and a y that when I put in the x, I get out that y value for this equation. So maybe I put in an x value of 4 and I get out a y value. Well, the solution to this system means that I also put in a 4 to my second equation and I get out the same y value that I did above. So a solution will be an x-y pair that makes both equations true, and we are going to find the solution by graphing. So I'm going to graph each line separately in the same coordinate plane. Each line represents the possible solutions for that line. So here my slope m is positive 3 over 2, and my b is positive 3. So I go up to 3, and then I use my slope to go up 3, right 2, and find other points on my line. Now I've run out of graph, but I can still go down to the left. So I know that a negative 3 over a negative 2 will also, when I divide two negatives, give me a positive 3 over 2. So I can go down 3, left 2, down 3, left 2, down 3, left 2, and so on until I reach the end of my graph. Now we draw as accurate a line as possible because we want to make sure that when I find my solution, it is the accurate point. So there's the graph of my first line. My second line has a slope of 1/2. Just like above, we can also change both of those signs. The top one I can make -1, the denominator I can make a -2. And my b here is a -1. So I go to -1 and I put a point on my graph. And then my slope says I go up 1 and right 2, so up 1, right 2, up 1, right 2, up 1, right 2, until I reach the end of my graph, and here I am at the edge of my graph. So my next option is to go down 1 and left 2, down 1, 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 left 2, and I have reached the edge of my graph. So now I connect all these points as accurately as possible, and my graph would look something like this. Oops. So with that in mind, I am looking for the solution to both equations. Now anything on this red line is a solution to my first equation. Anything on the blue line is a solution to my second equation, which means if they have any points in common, then that point is a solution to both equations. So this point right here where they're cross, that would be the point -1, 2, 3, 4. So -4 for x and -3 for y is a solution to both of my equations. So what we're saying is if I take that first equation and I plug in a -4 for x, then I should get a -3 for y. So let's try it out. So I'm going to try x is equal to -4, and I want to get out a y value of -3. So y is equal to 3 over 2 times a -4 plus 3. -4 is also -4 over 1, so that might help me calculate this a little bit. So y is equal to 3 times -4 is -12, 2 times 1 is 2, plus 3. So y is equal to -12 divided by -2 is a -6 plus 3. -6 plus 3 is a -3. So I put in a -4 for x, and I got out a -3 for y, just like this point says I should. I'm going to go ahead and try this now for my second line and make sure that it works for both. So for my second line, I'm going to put in an x is equal to -4. So y is equal to 1/2 times x, but x is -4, minus 1. I'll put my -4 over 1 so I can multiply my fractions. 1 times -4 is -4. 2 times 1 is 2, minus 1. So y is equal to, when I divide -4 and 2, I get -2 minus 1. Here I've got two negatives and one more negative, so y is equal to -3. So again, I put in a -4 for x, and I got out a -3 for y, just like this point says I should. So for both of my equations, I put in an x of -4, got out a y of -3, put in an x of -4, got out a y of -3. This is the only point where I can put in the same x value and get out the same y value. So my solution to this system of equations is -4, -3. Go ahead and take a moment to pause the video and practice this next one on your own. My first equation, I've got a slope of negative 2, or I can write this as negative 2 over 1. Or I can change the sign of both and have a positive 2 over a negative 1. My b is a positive 5, so I go up to 5 on my graph, and then down to right 1 as many times as I am able until I run out of graph. Similarly, I can go up to left 1 until I run out of graph. Drawing my line looks something like this. For my next equation, I've got a slope of 4, which can be written as a fraction as 4 over 1. Or I can change the sign of both numerator and denominator to get negative 4 over negative 1. My b value is a negative 1, so I go down to negative 1. Up 1, 2, 3, 4, right 1. Up 1, 2, 1, 2, 3, 4, right 1. And I can already see the point where the two lines cross. So in this case, I actually don't need to continue my line because I can see the point that I'm looking for is right here. That point has the coordinates positive 1 for x and positive 3 for y. So my solution to this system of equations is the ordered pair positive 1, positive 3. So if I plug in a 1 for x, I will get a 3 for y in my first equation and in my second equation. All right, you've got a few more to practice, so go ahead and take a moment to pause the video again and practice these next few on your own. So for my first system, I've got my red line with a y-intercept of negative 2 and a slope of positive 1. And then my second line is my blue line with a y-intercept of 4 and a slope of negative 1. So the two lines cross at 3, 1, which means for both lines, when I put in an x value of 3, I get out a y value of 1 for both equations. Similarly, for the second system, I graph my two lines, and they cross at negative 4, 1, so when I put in a negative 4 for both equations, I get out a positive 1 for y for both equations. Now lastly, we did need to use our skills of isolating your y in both equations. Or you can just make a little chart and graph using an XY table. So for example, I could put in a 1, a 0, a negative 1, and build a chart and then graph my line that way. I chose to isolate my y by subtracting the 2x from both sides to get my first equation. And then in the second, I subtracted my 3x, and then I had to divide by negative 2 to get to my slope-intercept form. Either way I graph, and I find a solution of 2, 1. In our last examples for today, I'm going to have us test whether these ordered pairs are solutions to the systems of equations. So all that's saying is, hey, I think this is an answer, so let me try putting in an x value of 2 and seeing if I get out a y value of 5 for both equations. So for my first equation, I'll go ahead and do this one in red like I normally do my first equation. I'm going to put in an x value of 2 and figure out what y value I will get out. So when I put in an x value of 2 for my first equation, I get out a y value of 5, which is what I wanted. So that solution works for my first equation. For my second equation, I put in a positive 2, and I want to figure out what I get out for y. So 4 minus 3y is equal to negative 11. I subtract 4 from both sides. Negative 3y is equal to negative 15. Dividing by negative 3, I see that I do get a y value of positive 5. So for both of these equations, I put in an x value of 2, and I got out a y value of positive 5, just like we were supposed to. So the answer to this question is that yes, 2, 5 is a solution. Go ahead and pause the video and practice these next 3 on your own. For my first system, I see that negative 2, 0 works for the first equation, but in the second equation, I get out a 2 instead of a 0, so negative 2, 0 is not a solution. Similarly, you can check those last two for 1 and 2. Thanks so much for watching.